The following reaction was studied. NO2 plus CO giving us NO plus CO2, and the rate law was determined to be rate equals K times the concentration of NO2, that quantity squared. Propose a mechanism for this reaction. In the previous video, we talked about criteria for mechanisms, and we mentioned that mechanisms are made up of elementary steps. These elementary steps have molecules coming together, and the name that we come up for this is called molecularity. Okay? If one molecule is involved in a particular reaction, we call it unimolecular. 2 molecules, bimolecular. 3 molecules, termolecular. We also said that the mechanism must agree with the rate law, and the slowest step is going to be our rate determining step. Okay? In this particular rate law, we have rate equals K times NO2 squared. Okay? So in order to agree with the rate law, we have to have NO2 plus NO2 giving us various products. Now, if we look over here on the product side of the reaction, we have nitrogen monoxide, which is NO. So we know that has to be one of the products. So what else could result here? We have 1 nitrogen and 1 oxygen on the right, and over on the left we have 2 nitrogens and 4 oxygens. So our other product has to be NO3. Okay? And this is telling us that we're going to have here a bimolecular reaction, and that comes from the order of our particular reaction. And this particular step here is going to be our rate determining step. Okay? Or we could say this is going to be our slow step of the reaction, because this comes from our particular rate law. Okay? Now we know that on the reactant side, we're going to have CO present, so that has to come over here, right? And we also know that this overall equation down here has to be NO2 plus CO giving NO plus CO2. Okay? So that means that over here on the right-hand side, we're going to need a CO2 molecule. And over here on the left-hand side, we need to have an NO3 over here. So each of these cancel out. Okay? In terms of what that gives us over here, we have a nitrogen, 4 oxygens, and a carbon on the left. And we have a carbon and 2 oxygens on the right. So that means NO2 also has to be present as a product. Okay? So if we add these together, the NO3s here cancel out, and one of the NO2s cancels out with one of these NO2s over here to give us our overall reaction. So species that participate in elementary steps of a reaction but are not involved in the overall reaction are referred to as intermediates. And for this particular reaction, our intermediates are going to be NO2 and NO3. Okay? So let's see here if this particular proposed mechanism satisfies all 3 requirements. The first, the sum of the elementary steps must give the overall balanced equation. And when we add these steps together, we get NO2 plus CO giving us NO plus CO2, which is the reaction that was studied. So that maps out. The mechanism must agree with the experimentally determined rate law. Here we have a bimolecular elementary step here that comes from the rate law. Okay, the rate law gives us our rate determining or slower step. two NO2s come together to give us an NO plus an NO3. This agrees with our rate law. So these guys check out right here. Okay? Then the slowest step is our rate determining step. We add everything up together. We introduce this term called intermediates. And this is what we would write down as a proposed mechanism for this particular reaction that was studied when we were given the rate law that we have here as K times NO2 squared.